Okay, let me make this a little bit bigger. Let's see. That should be getting darker as we go here. All right, so the first ones I just had you plugging things in. Just to get used to plugging them into the formula, setting it up. You're given a principal, an amount to start with, a rate, 10 years, and they change that how many times you compound. So if you compound annually and it's 1, 2, semi-annually, quarterly, monthly, daily, continuously. Everybody okay with that? Stop me if you have any questions. Is this the wrong sheet?
No.
Yes.
If you have a question like this on the test, where it's like that, do you want us to write out like every single plugin and everything, or if we just wrote the general equation?
You have to at least give me this equation. You have to show me this, and then
Every
just
time?
oh yeah.
Okay.
Yeah. You have to show me all substitution. Remember, you guys have to show everything in your work. And the reason we make you do that is when you get to calculus, you have so many little tiny minuscule steps that if you don't show, that it doesn't, one little wrong problem then makes the whole problem wrong. So every little step, yeah. Uh-huh. And remember, money rounds automatically to 2 decimal places. Otherwise, you're still rounding to 3. You should see that PERT gives you the best rate, even over a 365 or 365. Even over the 365, PERT is better. It's a continuous, but not a whole lot better, but something. You can see the difference between the annual and the PERT, at least. That's a big difference. Good? You good? Or not?
I think it was a calculator that I used.
Yeah, alright.
No, because I plugged it in, like, I had it set up for this.
Okay, but here's the thing, too. When you use your calculator for this, is it raising to the thing, or did you have to use a caret?
I used a caret.
Okay, so this is it. So if you use the caret and you say times 10, what the caret does is it raises this to the 4th power and then times 10 to your answer. So if you have a caret, this has to be in parentheses. That's a problem. That's probably what went wrong. On the 83s, this is a major issue, guys. The 84s, they pop it right up there, so it's not a problem. But when you raise, look what order of operation does. It does exponents first, so it's raising to the 4th, and then it takes your answer and multiplies it by 10. So be careful. So you got phenomenal numbers there, right? You made really good investments. Yeah. We wish we could make investments like that. All right. As long as you know what your problem is, you're fine. And it probably happened to you here as well. Another way just to, this time we changed time on you instead of rate. We left your rate continuous, and it was a PERT, so you didn't have to worry about that, just to get used to using this. We're good? And again, compound monthly. You're changing your rate again just to see the difference in what happens when I use PERT and compound it continuously. I compound monthly. I went to a bigger rate. Where are my differences? Depreciation. I know a few of you had a little bit of question about this. So the car is depreciating. What percentage every year is it depreciating? What rate does this say that it depreciates? So it says 3/4, right? So it says 3/4 that I retain. So what value does it depreciate? It was 1 minus 1/4, right? So I'm retaining 3/4 of my car, or 75% of my car. So what part am I depreciating? A quarter, which is 25%. So I lose 25% of my car every year. I depreciate it. So if your car costs $20,000, 25% of $20,000 is what? It's a quarter of it, divided by 4. $5,000. So now your car costs $15,000. So I'm still depreciating it by 25%. So now how much am I depreciating that car? A little bit less than 4,000, right? So where is your biggest depreciation? In the beginning, because that's when your car costs the most, right? It works the opposite of the increase. The increase, it get kind of slow at first because you're doubling or tripling, and then all of a sudden you got bigger numbers to double and triple. Depreciation works the opposite. You start with the biggest number, you take the biggest chunk off, and eventually, like your half-lives, think of your half-lives. Your half-life of a substance never reaches 0. There's always something left to it, little tiny left to it, isn't it? Like it takes the biggest jump at the first half-life. So your biggest jump is right here in the beginning. So this is what it retains, 3/4. It really did depreciation 1 minus 1/4. So that's really 25% of your car that it's depreciating. I guess I know you guys haven't bought any cars yet, especially probably brand new cars. But and you hopefully don't have a loan yet. So, but when you drive out of the parking lot, your car is already depreciated. You could never get that much money for your car. Find the value of your car after 2 years. Everybody okay with that? Plugging in the 2? Okay. So again, it's going to happen up front because that's when the biggest value of your car is. And you can see where the jumps are. Just look at your table. If it costs $14,000, a quarter of it off is $4,000 to $3,500. So there's a big jump. As we get down here, not such a big jump anymore because you have less to take a quarter off of. Okay, it's a positive. All you have to do is just tell me, like in the front. If you kind of even just draw a graph, your depreciation goes like this. Doesn't it kind of just like jump the biggest thing right there? Even in can I just say one thing and ask next question? Even in Algebra 1, didn't you guys do like slopes of curves to find 2 points and figure out their slopes for functions? So you could find the biggest change right here in your slopes.
Sorry, why'd you use like 0.1386?
Where are you?
Part A is
Okay, all right. Why did I do 1 point?
0.1386. Why'd you do 0.1386?
Don't know what you're asking me.
Like, why'd you round it to 4?
Oh, I don't know why. Because a decimal, a rate usually will have just 1 here, but I figured I just went 4 decimals. I don't know, because when you move your percentage, you have to move it 2 positions over. So I just gave it a little decimal. You're fine with 3. You're fine with 3. That's my statistics class coming out of you. Well, what happens when you have a decimal and you have to change it to a percent, you're going to lose one of that. You're only going to get 1 position left over when you move it. So I probably just rounded it a little bit more. Be careful on this one. You're looking for your interest rate. When you put this in your calculator, your X is your rate.
For B, I plugged in like the rate. I only had 3 decimal places.
That's fine. Yes, that's fine. And whatever you guys plug in on your test, I do the same thing with your 3 decimal places. The rule of thumb. That is fine. That was the last one, right?
Yeah.
I don't know where this one came from. Oh, this is just like a little review I wrote here.
For 98A, you use natural log?
Yeah, because it's compounded continuously. But your interest rate is always given as an annual rate. It doesn't mean that it's compounded annually. It has to say compounded.
So I did it.
You have to use per.
Natural log.
Oh, I did this. You're right. I'm sorry. I did that with a log. I'm sorry. No, you don't. You have to intersect. You have to do an intersect. Yeah. But remember, your rate is very, very small. I don't know what that was.